Hello everyone and welcome back to Studify Success. We are back with the third and the last part of metals and non-metals. We have already completed physical and chemical properties of metals and non-metals, and if you have not seen those videos, go check it out. All the notes of this chapter are available in the description section, and for more study material you can always visit our website studifysuccess.com. So let's get started with the last part of this chapter. So we have seen various reactions of metals and non-metals with oxygen, with water, with other metals, with acids. Now we are seeing the reaction of metals and non-metals with each other. So what happens when metals and non-metals react with each other? They produce a salt. A salt is also termed as an ionic compound. What is an ionic compound? So an ionic compound is a compound formed by a positive and a negative ion. So a positive ion we know is called a cation and a negative ion is called an anion. Both of them, we know that positive and negative attract each other. Due to the attraction between this cation and this anion, a bond is produced due to electrostatic force. What is electrostatic force? Attraction between positive and negative is electrostatic force. So attraction between this cation and this anion produces a bond which is called as an ionic bond. This bond results in a compound which we call an ionic compound. So attraction between a positively charged cation and a negatively charged anion result in the formation of an ionic compound. An ionic compound is also termed as an electrovalent compound. So let us see this table. You must have seen this table. So this table shows us various types of elements. So we have noble gases, we have metals, and we have non-metals over here. You can see the complete table in your books as well. So we know noble gases are the one which have complete electronic configuration. So their octet is complete. What do I mean by an octet? So firstly we know, let's see the structure of an atom. So in the center we have a nucleus. This is a nucleus. The nucleus has a positive charge. Why? Because it has protons. It has positively charged subatomic particles which are called protons. So a nucleus is positively charged. Around the nucleus we have the electrons which are negatively charged. So these are the electrons which are present around the nucleus and they are revolving around the nucleus. So these electrons are attracted by the protons of this nucleus. This we already know. All the shells in which the electrons are revolving, they are in a definite manner, and we have particular shells in which a particular number of electrons are revolving. The innermost shell, so this is the nucleus, the innermost shell, which is this shell, is called the K shell. This is called the K shell. The next shell is called the L shell. The further next, the third shell is called the M shell. And if we have another shell, it is termed as the N shell. So we have 4 shells which are termed as K, L, M, N. These are the 4 shells. In the K shell can accommodate only 2 number of electrons. It can only manage up to 2 electrons. The L shell can manage up to 8 electrons. Further, the M shell can also manage up to 8 electrons. Okay, so we know that K shell can manage 2 electrons. Apart from the K shell, all the shells can have up to 8 electrons. Okay, so this is one thing. The second thing is every atom wants to be stable. Every atom, every element wants to be stable, and for that stability it should have 8 electrons in the last shell. So whatever is the last shell, it should have 8 electrons. It should have the maximum number of electrons, so it is stable. This is called the Lewis octet theory. So it says that the last shell should have 8 electrons. Whichever atom has 8 electrons in the last shell is a stable atom. Okay, so let us see now these noble gases. For example, let's see argon. Argon has 18 atomic number. What is atomic number? Atomic number is the number of electrons in an atom. So these electrons, the total number of electrons gives us the atomic number. So for example, we have argon. Argon has 18 electrons and thus the atomic number 18. Okay, if we start dividing, this is called the electronic configuration. This way of writing the number of electrons in terms of different shells is called the electronic configuration of any atom. So firstly we write 2 electrons in the K shell, because the maximum electrons that can be accommodated in the K shell is 2. So we give 2 electrons to the K shell, then the 8 electrons to the L shell, then the left 8 electrons are given to the M shell. So you can see in the last shell of this argon we have 8 electrons, which means that this is a stable atom. Why? Because it follows the Lewis octet theory, which says that it should have 8 electrons in the last shell. Similarly, neon also has 8 electrons in the last shell, and helium has 2 electrons. It is also stable. Either it should have 2 or it should have 8 electrons. 2 electrons in the K shell or 8 electrons in any other shell. So you see that all the noble gases present here are stable because they have complete configuration. So that is why we say that noble gases are stable compounds. Let's move to metals. For example, we have sodium. Sodium has electronic configuration 11. We start dividing this in different shells. So we give 2 electrons to the K shell, 8 electrons to L shell. Now we have distributed 10 electrons. We have 1 electron left, which we have given to M shell. Now you see the electronic configuration shows that in the last shell we have 1 electron, which means that this is not a stable compound. For this sodium to be a stable compound, it can either gain 7 electrons, so that it has 8 electrons, or it can lose this 1 electron as well. So you know that losing 1 electron is easier than gaining 7 electrons. So see here, we have this sodium atom. We have distributed 2 shells in the K shell, 2 electrons in the K shell, 8 electrons in the L shell, 1 electron in the M shell. So we have 11 electrons in total. Now this 1 electron is excess. If I remove this 1 electron, I'll attain the noble gas configuration. So this sodium loses this 1 electron and it becomes sodium ion. This sodium ion is a much stable form than sodium. Why? Because the electronic configuration of sodium ion has 8 electrons in the last shell, which means that this is a stable configuration. So sodium converts itself by losing 1 electron into sodium ion, which is a much stable form. And in similar manner, all the metals we have magnesium, aluminium, potassium, calcium, all these metals tend to lose electrons to attain a stable noble gas configuration. So we have 2 electrons, it tends to lose these 2 electrons. It has 3 electrons, it tends to lose these 3 electrons. Potassium and calcium has 1 and 2 electrons respectively. They tend to lose these electrons and attain a noble gas configuration. On the other hand, we have non-metals. So you can see, for example, we have nitrogen here. It has 5 electrons in the ultimate shell, which means in the last shell it has 5 electrons. Now it has again 2 options. Either it can gain 3 electrons or it can lose the 5 electrons. If it loses these 5 electrons, it is comparatively difficult and it requires more energy than gaining 3 electrons. On the similar hand, fluorine has 7 electrons already. It needs 1 more electron only to attain a stable configuration. So either it can gain 1 electron or it can lose 7 electrons. So it prefers gaining that 1 electron. Similar example we have here is chlorine. Chlorine has 2, 8 and 7 as the electronic configuration. It has 7 electrons in the last shell. So chlorine prefers gaining this one electron to become a stable chloride ion. Okay, so you can see that if we have sodium and chlorine together, sodium loses one electron. This one electron is gained by chlorine and it becomes chloride ion. Now we have a positively charged sodium ion and we have a negatively charged chloride ion. This positive and this negative ions attract each other to form an ionic bond and results in an ionic compound, which is NaCl. NaCl is a salt which is formed by metal here, which is sodium, and non-metal, which is chlorine. The salt form is NaCl, which is an ionic compound. How do we know that it is an ionic compound? Because there is electrovalent force, or there is attraction between the positively charged cation of sodium and the negatively charged anion of chlorine. So there is opposite attraction between positive and negative, resulting in ionic bond, which results in the formation of an ionic compound. So metals lose their valence electrons. Valence electrons means the electrons present in the valence shell. The last shell is called the valence shell. So it loses the valence electrons and forms cations. Non-metals gain those electrons in their valence shell and form anions, and the attraction between cations and anions result in an ionic salt. So this is what happens in the reaction of metals and non-metals. So now here we have some more things. Sodium and chloride ions, being oppositely charged, attract each other, we know this, and are held by strong electrostatic forces of attraction to exist as sodium chloride, which is a salt. So this is called the electron dot diagram, and this is how you represent whatever I have explained you in the previous slide. So sodium has one excess electron and chlorine needs that one electron. So this one electron is transferred from sodium to chlorine, and now sodium is positively charged, chlorine is negatively charged, and the attraction between them forms a ionic compound. The compounds formed in this manner by the transfer of electrons from a metal to a non-metal. Sodium is a metal, chloride ion here is a non-metal, are known as ionic compounds or electrovalent compounds. Here we have another example of magnesium chloride. Magnesium has 2 electrons in the valence shell, so it loses these 2 electrons and becomes magnesium 2 positive. Okay, then we have chlorine. Chlorine needs 1 electron to complete its octet and form a chloride ion. So this magnesium, because it has 2 electrons, it can donate these 2 electrons to 2 chlorines. So it forms magnesium chloride, which is MgCl2, which is again an ionic salt. So this is what an ionic compound is. The next we have are the properties of ionic compounds. So what are the properties of ionic compounds? How do they behave? So we know that ionic compounds are neutral compounds because they have positive and negative both, so they are neutral. They have electrostatic attractions between them, between positively charged cations and negatively charged anions. This is what we already know. The physical nature of ionic compounds is that they exist as crystalline solids because they have electrostatic force. Electrostatic force is one of the strongest forces. So this electrostatic force, due to this they have a solid structure. The melting point and boiling point, as I have told you earlier as well, electrostatic forces are one of the strongest forces. So if I have these 2 atoms, to break these 2 atoms I have to give some energy. To break this I have to give some energy. Now this energy required is much higher because of the electrostatic force of attraction. Because these 2 atoms are bound so strongly to each other that they need a huge amount of energy to separate them. So ionic compounds have high melting and high boiling points. Why? Because they have strong force of attraction among themselves, and huge energy is required to break these bonds. The solubility, the next property is the solubility. So these electrovalent compounds are soluble in water and they are insoluble in solvents like kerosene and petrol. Conduction of electricity. So in aqueous solutions, what do we mean with aqueous solutions? Aqueous solutions are when a salt is dissolved in water. So when a salt is dissolved in water, the ions act as charge carriers because they carry charge from one place to another. Hence, in aqueous solutions, the ionic compounds conduct electricity in aqueous or molten solutions. Why? Because the ions become free and they act as charge carriers. But in solid form, the ions are strongly held to each other by electrostatic forces and they are not able to move. Hence, they cannot carry the charge from one place to another and cannot conduct electricity. So in solid form they cannot conduct electricity, but in molten or aqueous form they can conduct electricity due to the presence of free charge ions which act as charge carriers. So we are here with the last topic of our chapter, which is metallurgy. What is metallurgy? Metallurgy is the process of extraction of pure metals. So we know that in the crust of the earth is the solid layer of the earth where we all live. So in that earth crust we have a lot of metals. Most of the metals which we use and which exist are present in the earth crust. So earth crust is the source of all these metals. So to extract those metals in their pure state so that we can use them, all of that processes and all of the studies involved in that is called metallurgy. So what is a mineral? We have often heard mineral, ore, we have heard these two terms, but we don't know what the difference between both of them is. Actually both of them are different, but we use them together often. But a mineral is an element or a compound which is naturally occurring in the crust. It is naturally occurring, it is present there. But an ore is the percentage, is some component of the mineral itself, some part of the mineral where the percentage of the metal is very high. So for example, if this complete portion is my mineral, but in this portion the amount of metal is very high, so this part is the ore, this part of the mineral is the ore. So mineral contains a very high percentage of a particular metal, and the metal can be profitably extracted from it. Such minerals which has a very high percentage of the metal and which can be extracted profitably, that minerals are called ores. So if you see, all ores were previously minerals, all ores are minerals, but not all minerals can be ores. Some minerals can be which does not have high percentage of metal, or that metal cannot be extracted profitably. So that mineral cannot be termed as an ore. So I hope the difference between mineral and an ore is clear to you. Gangue. What is gangue? So if this is a mineral, I may have various impurities in this mineral and in this ore as well, because they are existing in the crust, there are many impurities present. So gangue is those impurities. So ores mined from the earth are usually contaminated with large amount of impurities, and these impurities are called gangue. Okay, next these are some keywords which are important. We will study the complete process in the coming slides. Enrichment of ore is the removal of this gangue from the ore. So if this is an ore, so for example this is an ore and these are the impurities present in it. So the process to remove all these impurities and extract the ore only, that is called enrichment of ore or concentration of ore. I am concentrating the ore, I am removing the impurities and I am only using the ore. So that is enrichment of ore. So these are some keywords which we are going to study. But one thing which we need to take away from here is that the earth's crust has a lot of metals. We can see we have oxygen, silicon, aluminium, iron, calcium. We have a lot of metals which are present in the Earth's crust as well, or Earth's crust is the major source of all the metals, and the process of extracting it and using it profitably is studied under the metallurgy section of chemistry. So we'll move ahead with that. So the next part is the extraction of ore. How do we extract this? So this is a complete series of process. I have outlined all the series of events which come with that. The first step is the enrichment of the ore, which I have already told you. Enrichment of ore is so if I have, this is my metal, this is my ore, and it has various impurities in it. So the process to remove these impurities to concentrate the ore, that process is called enrichment of the ore. Now depending upon what the impurities, which means what the gangue particles are and what type of ore it is, what is the chemical and physical properties of the metal, of the gangue particles as well, depending on that we have various physical or chemical methods. We have various methods which we use to remove these impurities. We are not going in the depth of enrichment of ore. The main part we are studying here is extraction of the metal. So the second step, once we have the ore from the metal, from the mineral, so I had the mineral which was a bigger section. From that section I have extracted this ore. From this ore I have enriched it or concentrated it, and now I have the ore. We have the complete pure ore without any impurities. Now this pure ore, from this pure ore we need to extract the metal. So extraction of metal from the ore. So how do we do that? So we have classified, we have made 3 groups of metals depending upon their reactivities. We all know now what a reactivity series is and how are metals arranged in that. So based on that we have arranged the metals in 3 groups. One is metals of high reactivity, which we know the metals on the top side of the reactivity series, which are sodium, potassium, aluminium, all these are of high reactivity. So all these metals are grouped in this group. Then we have metals of medium reactivity, the medium elements. Then we have metals of extremely low reactivity. So based on their reactivities we have different processes to extract the metal from this ore. Okay, so for low reactivity we will study all this in detail. But for low reactivity, the low reactivity elements we know, gold, silver, platinum, copper, they rarely react with any substance. We have seen this in chemical properties of metal as well. So gold, silver, platinum, they do not react, they have very low reactivity. So they are often found in free state, they are found as it is. You can see we have a lot of gold mining because gold is found as it is. Okay, so gold, silver, platinum, these are found in their free pure state in the crust. But you know that oxygen is present everywhere on the earth, and oxygen is one of the major elements of the earth. Due to so much presence of oxygen, these metals often form oxides and sulfides. Okay, these form oxides and sulfides. So they form oxides and sulfides, they combine with oxygen to form oxides, and they combine with sulfate to form sulfide. So this needs to be removed, the oxygen and sulfide needs to be removed so that we can have the pure metal. So that is done in a proper way, we will study about that. Then we have metals of medium reactivity, which are zinc, lead and iron. They are found in the crust as oxide, sulfide, like the low reactivity elements, and also as carbonates. They react with carbon, oxygen, and they form carbonates. Then we have the high reactivity metals. They react with anything, whatever they find they can react with that, and they never exist as free elements. So they are never found as free elements. So we have different processes for all of them. You can see here, we will study about them in detail, and then you will be able to understand all of this in a much better way. So the first step we have is the enrichment of ore. The second step we have is the extraction of metal from the ore. So firstly we have the mineral, we take the ore from it, and from this ore we extract the metal. So from this ore we extract the metal, and now we have the pure metal. But this pure metal must also have some impurities, some sand, soil, water, some impurities must be there. So again purification is done to find a pure metal, which is done by this purification or refining of metal. So this is a mineral, this is a complete mineral. This part of mineral is called the ore, which has high percentage of metal. So this is the magnified version of the ore. This ore is having many impurities. These impurities are removed by enrichment of ore. Then we get a pure ore. From this ore we extract the metal by these processes, extraction. Then from this extracted metal we purify it to finally have a pure metal. This is a flowchart of all the steps involved in the extraction of metal. We'll first study them in detail and then we'll come back to this. So let us now, if you see this flowchart, it will be more clear to you. First we had the ore. We did concentration of ore, which means enrichment of the ore. Then we had 3 groups of metals. We did extraction of all the 3 groups. For the highly reactive metals, we did electrolysis of the molten ore and we got the pure metal. For the metals of medium reactivity, we had carbonate ores and we have sulfide ores. Carbonate ores were calcinated, or they underwent calcination and oxide was formed. Sulfide ores underwent roasting and oxide of the metal was formed. This oxide was then reduced to finally find the metal. This reduction was done by carbon or coke and by highly reactive metals. Metals of low reactivity had sulfide ores which underwent roasting and finally we got the metal. The last step after we get this metal is the purification or refining of metal. So which we have is, we have some impurities, we have to remove those impurities. So that is what we are going to see now. So we have done this extraction of the top elements also. Now we have purification of metals by refining. We call it electrolytic refining. So what we do here, again we have a battery, we have 2 electrodes, we have a cathode and an anode. So the impure metal which we got from the extraction in the last step, we make that metal, we make anode out of it, we make an anode out of the impure metal, and we have a small strip of the pure metal as well, and we make a cathode out of it. So this cathode is the pure metal and this anode is the impure metal. What happens now, as we pass the current, the electrons move towards this side at the cathode, because I told you cathode is the negatively charged, anode is the positively charged. So electrons move here and cathode becomes negatively charged. Cathode has the pure metal, I am remembering you again. Then anode becomes positively charged. Now you know the metal ions are also positively charged. So positive. So these metal ions, due to positive charge and loss of electrons, they come out in the solution, in the electrolyte. And yes, the electrolyte here is the solution of, for example, if I have copper metal here, so this is impure electrode of copper metal, this is pure metal of copper which has been formed the cathode, and the solution here, the electrolyte here is the copper sulfate solution. So it is the salt solution of the same metal which we are using. So the metal here is all same, we have impure copper, pure copper, and the salt solution of copper is here. So here also we have copper ions, so it comes in the electrolyte. These metal ions are removed from here and they come to the electrolyte. Now here there are a lot of electrons. These ions need those electrons because they are positively charged, so they move from the electrolyte to the cathode. They move to the cathode and they are accumulated on the cathode. As they get electrons, they become solid and they are accumulated on the cathode. So this cathode grows thicker and thicker. It has such accumulation of copper and it continues growing thicker and thicker and thicker, and at last it has all the pure copper is accumulated on the cathode. On the anode, the impurities, we have two types of impurities. We have the dissolved impurities and the insoluble impurities. So the insoluble impurities settle at the bottom and form the anode mud. The soluble impurities are become soluble and become dissolved in this solution in the electrolyte, but the insoluble impurities settle down as the anode mud. So we get the pure copper here. This is how purification of metal or electrolytic refining of the metal is done. So here we can see, on passing the current, metal ion from the anode here moves to the electrolyte, then transferred to the cathode due to opposite charge. Cathode is having negative charge, these ions are having positive charge, so they attract. Then from anode, soluble impurities dissolve and insoluble impurities settle at the bottom, forming the anode mud. And at the last, at the cathode, deposition of the pure metal is there, which we can use for any work which we have. This similar phenomena is used in electroplating as well. So I hope extraction and purification of metals and all the metallurgy is clear to you all. The last topic which we have is corrosion and its prevention. So what is corrosion? We have learned about metals, we have heard about corrosion earlier also. Corrosion is the deterioration of a material. Here we are talking about a metal. So corrosion is the deterioration of a metal by the action of moisture, air or other chemicals in the environment. The metal gets degraded due to the action of these substances. So rusting is the common corrosion phenomena which we have often seen, that iron particles in presence of oxygen and moisture, they convert into rust, which is a brownish substance which you can see here. Okay, corrosion of silver, you must have seen that silver particles, due to the action of sulfur from the air, they develop a blackish layer on themselves, which is Ag2S. Due to the presence of sulfur, they have a sulfide layer on themselves. Then we have corrosion of copper. We have copper utensils, various other substances of copper, due to moisture and carbon dioxide from the air, they develop a greenish film over them, a greenish substance over them. So all these processes are slowly and gradually damaging the metals and are degrading the metals. So how to prevent corrosion? Corrosion can be prevented by the following steps. So we can paint our valuable items with paints, oils or grease. So we have iron bridges, so we paint those iron bridges to cut the contact between iron and the oxygen, okay, which is present in the air. So to cut the contact, we paint it so that there is a layer of paint between them, or there is a layer of oil or grease between them. So to keep out air and moisture, we do this. Then we have alloying. So alloying is that we mix a certain other component in the metal. So the metal is not completely pure, it has some other component, some other non-metal as well, to get those characteristics or properties of the non-metal as well, and the alloyed metals become more resistant. So alloys are combinations of two or more metals, or metal or a non-metal, to get the desired properties. We can see alloy is an homogeneous mixture of two or more metals, or a metal and a non-metal, for those properties. Okay, alloyed metal is more resistant to corrosion than the pure metal. That is why we use alloys. So you must have heard about stainless steel. In that, iron is mixed with nickel and chromium. You have heard about brass. Brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Solder is an alloy of tin and lead. Okay, so now we know what an alloy is. These alloys have a lesser melting point than the pure metal. So pure metals have more melting point and boiling point in them. Alloys of mercury are called amalgams. Okay, so using alloyed metals rather than using pure metals can also prevent corrosion, because the alloyed metals are more resistant to corrosion. Then the third process, or the third preventive method we have, is galvanization. Galvanization is a process in which we coat a layer of zinc. So we have iron articles, we coat a layer of zinc metal on it. Okay, so that zinc acts as a protective layer, like the paint was acting as a protective layer, zinc also acts as a protective layer, and it prevents corrosion of iron. So that is galvanization. And electroplating, as I have told you in the previous slides as well, electroplating is a method of coating one metal on the other metal. So we paint one unreactive metal, like we had zinc in this case, we plate it over iron using electrolysis. So by the method of electrolysis, using electrodes, solutions, electrolytes, we paint or we coat the unreactive layer over another layer using electric current. So these are some processes by which we can prevent corrosion. So by this we are towards the end of the chapter, and thank you so much for being with me for this whole chapter. If you liked this video, please do like it, and for all the other details you can visit our channel. It has the other parts of the video as well. So we have covered this chapter in 3 parts. The first part has the physical properties, the second part has the chemical properties, and the third part has the complete metallurgy and corrosion part. All the notes are available in the description section, and for more content you can always visit our website studifysuccess.com. And thank you so much for being with me. Hope you liked the lecture. Thank you so much.